Question number 37 says, let f be a function where f of 0 equals 1. So that means that x is 0, y equals 1 for the f function. And we're given the derivative function, which is cos x squared. So part 1 says, find the linearization of f at x equals 0. For the linear equation, we need to know the slope and the x and y coordinates. So we already know the x and y coordinates. So I'm going to calculate the slope at 0 by plugging in 0 into my equation. And I get cosine of 0 is equal to a slope of 1. So my linear approximation equation is going to have a slope of 1 and an x coordinate of 0, y coordinate of 1. So my equation is y equals x plus 1. So using this equation, I can estimate the value of f at x equals 0.1. So we know that f of 0.1 is going to be approximated by the L at the same point. Okay, and if I use that linear equation, I'm going to get 1.1 as my estimate. So 1.1 represents the estimate of the value of f at x equals 0.1. So this is part B. Okay, so this is part A. Part C says, do you think the actual value of f at 0.1 is greater or less than the estimate in B? So what I can do is I can use the property that if it is concave down, the linear approximation is going to be above. And if the graph is concave up, the linear approximation is going to be below. So I want to know what the concavity looks like. And to do that, I'm going to find the second derivative. So I differentiate the first derivative. I'm going to end up with negative sine x squared times 2x. And then I'm going to evaluate the concavity at that point. So, I want to know what the concavity is along that line where I'm estimating, which is going to be at 0.1. So if I put in my 0.1, I know the sign is going to be positive, the 2x is going to be positive, so my concavity is going to be negative. Okay, so that means I have negative concavity. Well, if I have negative concavity and my tangent line is approximating that point, I'm going to have an overestimate. Okay, so the estimate is greater. Or we can say that L of 0.1 is greater than f of 0.1.